I'm going to do a video on relationships and graphing and how to state the type of relationship. And if you use this language, it'll make a lot of the problems, I think, a little bit easier. So let's do an example. Let's say I'm going to drop a ball and measure how long a time it has fallen for, and then the distance that it falls in that time. So my data would be time, call that 60 seconds, and then I'd have distance, fallen, and we might say that's 50 meters, and we get my data. Now I know that the longer time it's fallen for, the farther it's going to fall, but is that going to make a straight line, or is it going to be something a little more complicated? So when I graph it, I graph D versus T, and I end up with a curve that looks like that. Now, how am I going to straighten that? Well, the first thing I might try would be D T squared, and when I do, I find out that it comes out to be a nice straight line. And I find the slope of that line, and the slope ends up being 5. So then I compare that to y equals mx plus b. On my y-axis I have d, my slope is 5. On my x-axis I have t squared, and then the intercept was 0, so I don't have to worry about it. So that's my equation. And I think we're all getting pretty good at doing that. Then I might ask this question. If the ball has fallen for 3 seconds, how far is it gone? And we know how to do that too, right? We're going to plug into that equation. So d equals 5 t squared. D equals 5 times 3 squared. And we do that, we'll get the distance of 45 meters. So we can answer that question. We can also answer this question. If the distance, if the time doubles, what happens to the distance? And what most of us have been doing so far is something like this. We had a distance at a time of 3. Now we're going to plug in a time of 6, so we're doubling the time. So 5 times 6 squared, and that's going to give me 180 meters. And then to figure out what happened, I could take 180 divided by 45, and that gives me 4. So D is 4 times its large. And that's okay, and that is a way to do these problems. However, I'm going to use a little different language, and it might make these a little bit quicker. The language I'm going to use is this. When I see a graph that looks like this, d versus t squared makes a straight line, has a slope of 5. I can write the equation d equals 5t squared, or I can say this, d is proportional to t squared. Okay? One thing, if it's proportional, it's going to make a straight line. So d and t make a straight line. So I can say d is proportional to t squared. You can write it like this. D is proportional to t squared. This little symbol here looks like a fish swimming to the left. Its Greek letter alpha stands for is proportional to. The reason this is kind of neat is when I say if t doubles, d does what? You can just do this. Plug in the 2 for t. So d is proportional to 2 squared equals 4. So then you can say d will be 4 times as large. So it's a little bit simpler. So whenever you're reporting a type of relationship, rather than you can say d is proportional to t squared. It's a nice simple way to say it, and it makes these doubling and tripling problems a little bit easier or quicker.